Hello, welcome back. Let's solve another challenge today. Today's daily question is from Leetcode 1267. Count servers that can communicate. So let's see what the problem statement is. So we are given a map of server center represented as a m by n integer matrix grid, where 1 means that on that cell there is a server and 0 means that it is no server. Two servers are said to communicate if they are on the same row or on the same column. So we need to return the number of servers that can communicate with any other servers. So basically, so we need to see the servers to be able to communicate. Either they have to be in the same row or in the same column. So we need to count the number of servers. So in the first example, you can see the first server is in the first row, first column, and the second server is second row, second column, and they are not sharing a column or the row. So we need to return 0 because the service cannot communicate. In the second example, we have 3 servers are given, and the first, all 3 can communicate. Basically, the first server here can communicate with this one, and the second server can communicate with the third one. Basically, all of the servers they can communicate. So we need to return the 3. So in example 3, we have 5 servers. And the first 2 in the first row can communicate, and 2 servers on the third row can communicate, and one more server in the last row cannot communicate, right? So let's see what are the constraints. So m is the length of the grid. N is length is a row, and n is a column of the grid, and m by n or m can range from 1 to 250. And the grid values can range from 0 to 0 or 1, right? So let's see how we can solve this problem with the examples. So let's see the first example. So we have basically 3 servers are given. And what can we do to be able to count the number of servers that can communicate, right? This is basically... let's increase this. This is a number of rows. Basically, I can say the row 0, and this one is row 1, and this is column 1, and this is column 0, right? And the first thing that came as a solution is basically counting this as number of servers as a part of an island, right? Like number of islands that we can use the grid traversal, right? BFS or DFS, right? So then I tried that one. It looks like that's a little tricky to implement, and because in this example, all 3 they are a part of an island, right? And this is like we can easily do the BFS with this. But in the case where, let's say, we have a grid, we have a server here, we have a server here, and no server and a server, and no server and the server, and let's say server, right? No server. So this one, right now we can see here there are 2 servers they can communicate, right? But if you want to do the BFS, and you cannot, then if you do BFS, and you need to return each island, right? Each island, they should have at least 2, right? basically at least 2 elements in the 2 servers in each island, right? If it's more than one, so we can count the number of servers and we can add the total to the total number of servers, right? Like in this case, we cannot do that because how you're gonna run the BFS, because there is no connect in there, right? And we can get this one, we need to return 2 here, right? If you do BFS and then start counting number of elements, then that we cannot implement the BFS directly, right? So instead of doing this tree traversal, so we can do something else here, right? What we can do, we can count the number of, we can keep the counter, and we can start, let's say, yeah, we can start from the very first cell. We can start from the very first cell, and we will just say, okay, the row, right? Row, we say the row count and column count. Like we'll see in the first row. So what first row is basically the row 0, right? There's a row 0, row 1, 2, and 3. And the first row, we'll say this will basically I can keep the dictionary. First row, I will see there are 2, right? 1, 2. First row, there are 2 elements, right? 2 servers. And the second row, there is second row is like first, right? There is only 1, and the third one there is only 1, and only 1, and the last one there is only 1, right? And the same way I can count the number of elements, servers in the column, right? So what I will do in the first column, there is 1, and the second column there is 1, and the third column there are 2, right? Basically there are 2 elements in the second column. I mean this one basically in the third, right? In the second column there are 2 elements, and the last column there is a 1, right? After I do this, basically I will just go through the 4 row in rows and 4 column in columns. Then I will just check if it's 1, basically grid row and column is equal to 1. Then I will increment this row count, right? Initially, I will just initialize the row count to be kind of counter, right? And then if this is this 1, then I will say row count row. I will basically increment this one, and row and not row, but it's gonna be a column, basically column count column. Then I will increment, right? So this will basically this loop will basically return this to dictionary. I will basically count the number of servers in each column in each row. Then I will run another loop. What I will do then in this loop for row and for column, then I will just say if row and column elements are this basically whatever is element is bigger than 1, then I will just increment the number of servers that can communicate. So in this case, when I go here and I will check for the row, right? I will check for the row. For this row, I will check, this is 2, right? I will, this is total count, 0. Then I will check if the row count is more than 1 or column count is more than 1. Then I will add this uh, to the one, right? To the count. Imagine that we have right now for this row we have 2. Then I will add this one. Basically, it will be +1. Then for this row, it's still row 1. It will be +1. Then I will go to the second one. For the second row is 1, but column for this specific column, second column, I will see there is 2, right? Then I will add +1. Then I will go to the next row, but the same column, it will be +1, and total will be 4. So basically, I have to return 4. So this will be very clear after we see the code. So this is a code. If there is no grid, so we need to return 0. Then we compute here number of rows and number of columns. Then we initialize either we can do the counter or we can do the simple dictionary, the row count and the column count. We initialize. After we initialize the column count, row count, then we go through each cell for row in the range rows and for column in the range columns. And if the grid row and column is equal to 1, then we increment the row count, we increment the column count, right? If it's 1. Then here we initialize the count to be 0. Then we go through each cell one more time for the row in the range rows, for the column in the range column. And here is the trick, right? If the grid is 1 and row count is more than 1, or the column count is more than 1, basically that row has 2 elements. They may not be adjacent to each other, but they are in the same row, right? Then we increment the count. Then at the end we return the count. So the time and space complexity, here time complexity is O of m times n, and space complexity is O of m plus n. So the time is O of rows, rows times columns. Even though we are going through this each cell twice, right? Basically, it will be 2 times, right? 2 times, but the time complexity will be still row times rows, number of rows times number of columns, and space complexity will be O of rows plus columns, right? So that's it for this problem. If you have, I hope this is clear. And if you have any questions, please feel free to leave a comment. Thank you. See you in the next video.